I'm going to be talking about the future of machine health and Industry 4.0, two topics where our business is focused. Now these are big topics, and I can't cover them, I can't do them justice in the next 20 minutes, but what I can do is offer a much more targeted perspective on them that will hopefully help you take one step closer to really being able to take advantage of them. Okay, so I'm going to talk about helicopters to start off with. Interestingly, helicopters are they present one of the greatest maintenance and reliability challenges of our time. And secondly, as Ben had noted, the helicopter industry was working on Industry 4.0 well before Industry 4.0, the term, was even coined. And so this offers us a nice opportunity for foreshadowing about what this is all about and where it's headed. So why it begs the question of why helicopters? Why were they ahead? And there's some government money that was involved, but also helicopters, in order to have any substantial payload lifting capacity, they have to design the components to be fragile. They have to design them, they have to trade the weight of the components for essentially the longevity. And so each of these components are fatigue life limited. So within that, what that means is in a normal operating regime, these helicopter components are actually expected to fail. And so what you have to do is you have to be very carefully pinpoint when your PMs need to happen so that you can pull those components before they fail. Now that presents two big problems, right, or two big challenges. Number one is you have to do a lot of maintenance on these helicopters. So this is the CH-53K. It's just going into production this year. It's a Sikorsky helicopter. The predecessor to this was the CH-53E. And that helicopter, they had to do 40 hours of maintenance on that helicopter for each flight hour for that helicopter. It's just incredible. So a helicopter would fly, let's say accumulate 10 hours of flight time in missions. It would land on the aircraft carrier. A crew would jump on that helicopter and start tearing off components, inspecting the helicopters, and they'd have to spend 400 hours just to get it ready to go back out. It's quite remarkable. So that's the first challenge. The second challenge is that helicopters still fail, right? And when they fail, they fall out of the sky. They're just to put it in perspective, we all know cars are dangerous and, a leading cause of death. If you fly in a helicopter for one hour versus driving a car for 1 hour, you're 40,000 times more likely to die in that helicopter. and so it's mind-boggling. And, so the Navy said this is just unacceptable. We have these massive maintenance budgets around here that dwarf the life cycle costs of these aircraft, and we still have our helicopters falling out of the sky. We need to do something about this. And so that's how they got down this path. And they discovered two interesting things. Number one is most of the time, the PMs were extremely overly conservative. But some of the time, the PMs were not nearly conservative enough. And in those times, what was happening was pilots were flying outside a normal operating regime and doing extreme levels of damage to those components. And so taking this in, the Navy said, okay, the solution here is that we actually need to know what's going on with that helicopter in real time. We need to measure the actual damage that's occurring to those components, and then we can be much more precise about when we're doing those PMs, when we're removing those components and replacing them. And so that's just what they did. So they built a digital twin of the rotor assembly. Our involvement in this project was building an energy harvester powered wireless load sensor that went into one of these load links here. We also did work on the gearbox assembly where we were building, this is the sensor that we built for the gearbox. It's a energy harvester wireless accelerometer. that measured gearbox vibration, much like our vibration sensors, our battery-powered versions. So the government built this digital twin, and what this is providing them is clarity on how to retrain pilots to avoid those operating conditions that do excessive damage, and they're able to adjust their maintenance programs in real time. This is Industry 4.0. This is where the machine health part of Industry 4.0 that we are focused on, and we believe that this is the future. And notice, Ben had mentioned our work in the government. This is really our foundation. It's one of the things that sets us apart as a company. This is where we came from. We didn't come from some technology. We aren't a Silicon Valley startup. We start with what is the real need, and then we work backwards towards what is the right technology to support that. It sets us apart, and on one hand, we're always on the right path, but because that's what we're exploring. Sometimes our technology is following that, and so we might not always have the best AI right now, but we will have the right AI because we are on the right path. Okay, so for the helicopter industry, it's straightforward. The consequences of failure are just so high. But for the rest of the industry, it's much more complicated because you have this cost side that's so important. And so it begs the question, is this hype or reality? What is really happening with Industry 4.0? And what we've seen, the big change that we've seen in the last few years is it's very clear it's happening right now. We can pretty much, across all industries, agree on that front. But there's two questions remain. It's when to invest and what to invest in. You don't want to invest too early, and you need to be targeted in what you're investing in. And the reason these questions are important is because industry is we're low on the digitization curve here. There's not a template for how to do it right. Okay, so to address this, I think the best way to think about it is looking at what happened in the past. So, if we look at what actually happened in the third industrial revolution, we're in the fourth now. What actually happened in the third industrial revolution? Well, let's look at this graph here. So this is a blend of the labor resources across the U.S. economy and how they changed. Manufacturing is shown in the dark blue there. And you can see that it shrunk dramatically. Those resources distributed across the rest of the economy. This is not a story of decline of manufacturing. It actually grew over that period substantially in the United States. But it's a story of disruption. When technologies like automation, which was the third industrial revolution, when automation takes hold, it creates massive disruption in industry. So what was that disruption? Well, what happened was automation enabled the work output per labor hour within these plants to go dramatically up by a factor of 3. So those machines are less expensive to run than it is for a human to do that work. And that just drives great gains. And of course, the trend in the automation sales over that time period is, I would say, is a causational relationship here. Okay, this is, what we have to be looking for here is how that impacts industry, how these disruptions impact industry. And the way it typically works is it creates, it doesn't necessarily, disrupt in a whole industry into decline. Rather, it just creates winners and losers in industry. And this is not a perfect graphic to show it, but basically, so this was the green that you see here is over 50% growth over the Industry 3.0 period, and the red is over a 50% decline over that time period. And so, what was actually happening is just the winners, the adopters of this technology, grew tremendously, and those who didn't declined. And that's really what we need to be watching for here with Industry 4.0. that there are disruptive technologies that are going to push similar change here, and we need to take advantage of those. So it begs the question still of, when is the right time to make those investments? And the way to look at this, I believe, is to look at leading indicators. There's two leading indicators that are most relevant here. The first is the technology. Is the technology maturing, and has it matured? And patents are a good representation of that. So this figure shows between 2000 and 2020, the blend of patents associated with AI dramatically increased from 6% up to 17%, but is just leveling off now. Last year, I think it was like 16% of all patents. So what we see here is the technology is mature. The second piece that we need to watch for is investment in this space. Back in 2000, there was really nobody in the IoT machine health space. In 2010, we were among just a couple companies doing it. And today, I would say there's roughly 26 companies that are legitimately in our space. Now, they're not all the same. Scalability, the reliability of the products, the maturity of the products, the capability of the products is different. But nonetheless, what this tells us is there is tremendous investment going into this space right now. And that gives confidence to know, for us to know as a whole, that this is really moving forward. And this tells us, now is the time. Industry 4.0 is happening right now. This is the moment where we're going to start to see divergence between the winners and the losers in this space. Okay, so from an investment perspective in this technology, we saw this in several of the other presentations too. There's key criteria that have to be met, some fundamentals here. The first is, the technology has to be mature. The second is the value proposition has to be proven. And third, we need to be able to transition this practically into the plants. And what we've seen is over the last couple years in particular, all three of these boxes have been checked by some of our best customers. So we know it's ready. We know that this is moving forward. So, all right, so that's the piece of when, but there's something more. So what particularly to invest in? To answer that, we first have to make sure we understand, what is Industry 4.0 all about, particularly within the machine health space. And to answer that, I could give a technical answer, and there's been so much written about it. Most of what you read is about the technology, databases and AI. What really matters, though, is how is it going to impact our plants? Like, what is the real game changer here? And I think of it in terms of two things. Number one, it's much better insight into what is actually happening right now in manufacturing plants. And number two, it's foresight into what is coming. What can you forecast is going to happen that you can then take action now to avoid? And of course, there's automation that plugs into all this and visualization. But the real game changer here is this. It's the insight that's driving that. Okay, now the insight is not going to come from a supercomputer that's off somewhere else. That might work for some, the financial sector, but in the manufacturing sector, this AI has to be, and this intelligence has to be coming from specific implementations within that match the nuances of particular assets and particular industry sectors. And that's where we see our role. So how is this insight going to impact, insight and foresight going to impact manufacturing from a practical standpoint? We heard a lot about downtime. And of course, that's a key thing. And this is obviously an oversimplification, but there is one point that I want to make here. Of course, just run more, spend less. So this is on the vertical axis, we're looking at dollars per unit produced, and on the horizontal axis, volume. And then you have your variable costs that are increasing with your production volume, tracking per unit with your production volume. And then you have your fixed costs here, right, that are being amortized as you increase volume, being amortized across more units. And there's your profit. Okay. The key thing here, and what's so powerful about running more, is that you're gaining profit margin. Your profit margin on the new units that you're producing is bigger, right? And so by running more while holding your costs the same, you are gaining a compounding effect on that margin. So it's not linear. Okay, and the second thing, if we can increase not just the availability of our assets, but we can reduce the cost, the capital cost associated with the replacement of those assets, and then also the maintenance dollars that we're spending, the labor resources on those, we can pull that cost down. And there's the third compounding factor, or the second compounding factor that really drives revenue. And that's ultimately, drives profit, which is ultimately, that needs to be the bottom line of this technology. So just in the near term, this is not a perfect this is not representative of all industries. This was just a survey of one paper mill, but so it's just representative. It just shows us here that unplanned downtime is the low-hanging fruit here, and it's addressable. And so this is the near term. This is predictive maintenance, of course, but there's a deeper story here. So the first element here, is this predictive flow. So it's the relationship between equipment and maintenance. Okay, that's basically just predicting a failure. Then there's this relationship between maintenance and process. Are there things that the maintainers are doing that are stopping maintenance or stopping process? Of course, that's just downtime. And then third, are there things that the equipment is doing that's affecting process? Normally, that might be in the case of a quality or a defect that's occurring because the equipment is not running optimally. So this is the basics. There's something to unlock the full value potential of Industry 4.0. There's the inverse of this. And so this is really where we need to move. This is really where we are headed with smart diagnostics and our company in general. So the first is the relationship between maintenance and equipment. So it's how is the way we're maintaining equipment affecting the life of that equipment? So that's over-greasing bearings, for example. The second is how is process influencing maintenance? Can we run differently that would reduce the number of PMs? And third, how is process impacting the equipment? How are hard stops prematurely wearing out the equipment? And that type of insight and foresight allows us to then answer much more complicated questions about, why does one line run more reliable than another? What is the true impact? What is the true cost of running faster? Let's say you're running faster in December to match a greater demand, and there's a cost there that we aren't typically accounting for in damage to the equipment. What maintenance can I eliminate? Maybe I'm doing too many PMs that are actually not productive. And finally, this is kind of on the ESG side of things. When I replace a motor, should I rebuild it, or should I replace it with a much more efficient one? The holistic picture of the asset, including ESG within the asset management, needs to be considered. I'd like to conclude just on a couple topics here. Or I'd like to offer just a couple insights to close out here. The first is on scaling, and I appreciated some of the comments that Suzanne made on this front, that this is it's the human element here that's so important. what we see is, technology, scaling the technology is almost just blocking and tackling. We can do that. We know how to do that, and we can, improve on that over time in a quite straightforward way. It's the scaling that's associated with how your technology is being used and the value that's being derived from it. That's the tricky part. And here's what I want to mention about that, or recognize. Before we really see a great impact on a great reduction in the actual time on wrench, we may need to see an overall increase in the amount of tension that needs to happen with our assets. And that's a blend of both the predictive and prescriptive part and turning wrenches. And then finally, we will see where we want to end up, which is less time on wrench and more time, analyzing and learning about the health of our assets and planning. And finally, although I think pretty much everyone recognizes there's not going to be like one holistic Industry 4.0 solution that covers all subject matters. What we are seeing is that there needs to be some level of consolidation of technologies, both on the user interface side and the sensor side. And this is something that KCF is paying attention to very closely and thinking about deeply, because this is really essential to a long-term foundation and long-term success for this. We're not looking at just today what needs to happen, but it's that longer range. What is happening in the next 5 years in terms of this technology space? And really where we see it going is on the user interface side. We need to see consolidation around value propositions and around user groups, right? And then on the sensor infrastructure side and data infrastructure side, we need to see consolidation around the types of data. So vibration is a totally different data type, essentially, than something like a process variable, and it needs to be handled differently. And the pipes that it goes through and the databases that it's stored in should be cohesive. Okay, I'm just going to conclude on a very positive note. These, of course, are the top 3 challenges facing the industrial sector today. And Industry 4.0 represents probably the greatest opportunity to address all 3 of these, not in their entirety, but to a great extent. And it's sitting right here in front of us. And so, I hope that, in order for this to really take off at scale, we have to be taking what we're doing on the plant floor and making sure it's mapping up to these more global corporate challenges that are faced. And then we will see that feedback loop to really grow this and let this stuff take off. Okay.
Thank you, Jacob. Aren't we lucky to have a smart guy like this figuring out the future of Industry 4.0? So I'm just attached to that train, as I know many of us are. Jacob, again, checking on that chat back and forth that as you were giving your presentation, a lot of chatter as you were describing the helicopter story, right? And I know you spent years working on predictive maintenance technologies and riddles for the U.S. military. When you think about the way that KCF is building out its Industry 4.0 platform, what is your biggest takeaway that you and your team learned from the helicopter days that you're baking into our solution?
Yeah, I mean, there's a lot. I mean, much of the technology that we're using today that's where a lot of the foundation came from. The wireless protocol is 8 times more efficient than the best standard wireless protocol out there. But probably the most profound thing was, and this was, the Navy actually acknowledged this or recognizes this, that they found was, through this program, was that the way pilots were flying the helicopters were doing dramatic levels of damage that they had no insight into before. I mean, many of these pilots, they're, in the military, you're getting that helicopter out of, in a combat situation, you're getting that helicopter out of there no matter what. You don't care about the helicopter. You're landing in terrible conditions, right? You're just putting it on the ground. And so they develop these techniques over time to fly it, and it sticks with them for years. And so they're often flying in kind of their own style. And some of those styles just are very expensive in terms of the reliability, safety, and the maintenance of those helicopters. And so, we see not exactly to that extreme in the manufacturing sector, but there's a really nice lesson there just about that connectivity between the operations of the equipment and the life and reliability. And we need to bring those two together.
I'm curious, show of hands, how many people here believe that their pilots, operators, might be flying your equipment outside of spec? What do you think? Yes, right? So, everything from the frequency with which we need to pull the data, the analytics to understand those little blips when we've gone into 10 G's worth of force or whatever it might be. That's the secret sauce, right? That's the key to Kaizen, continuous improvement, is understanding how the pilots are running the planes in the first place. Let's thank Jacob one more time. Nicely done.